In this video I'm going to be reviewing some circuit diagrams that somebody put on a web page to talk about how they're defending and discussing their invention of something. So I'm going to talk about one of the circuit diagrams first. I'm not going to show the diagram. I'm going to give you links to it. And I made a modified version of it to where it'll fit on the screen better, because one of the diagrams has a drastic change in font size and image size to make it much more difficult to review it. So, the first one I'm going to be doing is the QEG system conversion circuit number 1, and I've converted to a PNG on my screen because I'm not a troglodyte. And here we go. I'm going to describe what is in it. I'm going to go from left to right. It has something labeled QEG, and it shows split tappable transformers or some other object, secondary and primary. This is also being described as some sort of generator that you turn, and in their case they're using it off of a power line, running a generator, and then converting. So anyway, this circuit I'll be describing. On the left is a gas discharge tube set for voltage regulation. It's over voltage protection, not regulation. Next, what's called the secondary circuit on this is fed out through a variable resistor and a high voltage diode block to the primary circuit. Also on the other end of it is a choke to do something, and this goes to a capacitor that floats the whole boat directly above ground. So what is the primary of this circuit, because it's being labeled a primary? Well, an identical coil, or it's presumed it is, identical coil set is feeding out, or in, since it's primary, to a capacitor with a spark gap. And the other one has apparently the same thing. This may entail multiples. So what else is going on? Well, the next step is a capacitor in line with a bunch of spark gaps, with the symbol here is a set of taps that allow the positioning of a capacitor pair up and down the spark gap group. This is then coming from, or to, conventional wiring here says it's going to, the power transformer, which is using a similar set of coil things. And then this is fed through a capacitor into a full bridge rectifier. So that would be a LC compensation capacitor. So anyway, this is fed to a standard capacitor called capacitor tank. No, it's a filter capacitor. If it's a capacitor tank, that would indicate that it was at resonance or had a resonant component involving an inductor. There is nowhere on this that it's showing that. Then this is fed through, I call them sledgehammer diodes, a high current diode to a battery bank, which is then fed through another diode to a DC to AC converter or inverter to run your load. And it's by Tivon Rivers of QEG Academy. And of course it has a ground symbol where it's needed to be, and that's it. Now, where's the power coming from? Well, apparently a different circuit. So I'll be covering that other circuit next. Or not. Now, on the website itself it has a much clearer explanation, I'm sure. But I'll just get to the point on this. Spark gaps allow you to have isolation of power and also the ability to gauge voltages if you want to use a spark gap to gauge voltages. And gas discharge tubes can prevent voltages above a certain point. So having a primary and secondary coil set hooked up this way, apparently feeding back on itself, isn't an example of a perpetual motion machine. It's an example of an incomplete circuit for generating power, because it does end, it does terminate at a power transformer that's supposed to feed out a very conventional circuit. So there's no explanation on that side of what this is exactly able to do. But here's the deal. Spark gap circuits are usually DC pulses, and the diode block group seems to show that. So it would have to have some sort of power source. Now I'm presuming this is a secondary diagram, and that this is the actual output circuit, and it's called the QEG system conversion circuit. And this is supposed to put out your AC power. So we'll have to go with the idea that the object labeled QEG that looks like a slightly offset and then inductor, freewheeling inductor on the end of it, power transformer, similar symbols. I mean they're obviously repurposing a power transformer symbol, is our generator. So we'll call the QEG object that. Now we'll get to the other diagram. So this is the other diagram I'm looking at, and on the left is the apparent QEG. It's the one that's labeled everywhere else, but it's not labeled on this diagram. And it shows itself to be a primary and secondary circuit, similar idea. Capacitor tank, LC tank. It's called an LC tank because there's a coil of wire in the field windings of this object that I'm assuming is called the QEG. And it has another set of windings on the same field that's listed as secondary circuit. Now if we bounce back and forth, it appears to be correct, and its primary, as it's calling it, has spark gaps 2 labeled, and that's the LC tank, neutral ground, blah blah blah. So maybe it's the same thing. Now this is where things get confusing. What the hell does this do? I don't know, let's just go with it. Now what is this QEG if this is the QEG? Well, it's being displayed and indicated strongly in this circuit diagram to be a 3-phase generator at high voltage, listing itself as thousands of volts and using a set of spark gaps to prevent overvoltage, and something called an LC tank only on the primary circuit, and the secondary circuit uses its own spark gaps and its own low capacitor values fed out to rectifiers. Now I'm going to explain this really quickly. An actual 3-phase circuit, this is not a 3-phase power circuit. It's not indicating clearly that it can be one. Is a power circuit that you look at that has each of a set of wires, 4 wires, not 3, that provides one leg that's considered neutral, and it's electrically and mathematically in the middle of the circuit. You can say that. Basically, if you were to take a magnet and rotate it in a circle and have 3 coils of wire to pick up the magnetic field going by, it would pulse each magnetic coil once each time it rotates around, so you'd have 3 pulses coming out. And then the other side of the magnet would pulse it the other way. So you'd end up with 3 sine waves over the top of each other. Now if you rectify that by flipping all the waves up, you end up with a really efficient usage of the energy coming off of this generator, we'll call it. And that would be fed, if you want to a rather specialized transformer that works at specific frequency to convert it to the standard 120 AC we use, or you could use it as split 3-phase or whatever. I mean, there's 100 websites on this, and I'm not quoting that correctly. But the point is, this is not a 3-phase generator. It's called 3-phase at 4 kV, but it's showing in the diagram only 2 coils. It's indicating them as primary and secondary, so okay, and they're 90 degrees out of phase. But okay, let's assume it's 3-phase. So it does the standard thing where it feeds it to a set of diodes, and reference to each other, all 3 wires, this 3-phase rectifier takes the power signals from the 3 wires coming in and puts the positive charges over here on a capacitor, and the negative charges are dumped to a capacitor on the other end. But the thing is, 3-phase requires a 4th wire because that's the neutral you're using for a reference point. That isn't here. Next, this appears to be pulsed only because one of the legs, L1, only does positive pulses, L2 only does negative pulses, and then they're fed through a capacitor, so they only get the transitions of these snaps. The pulses, which I could presume are sine wave or square wave, are now only going to go one direction, and the only energy coming through will be the transition. So instead of the continual current flow, you're receiving pulse, pulse, pulse. Okay. And then one of the 3 wires is now being used for a center point, so this isn't 3-phase, this is 2-phase? Okay, we could do 2-phase. And it has then it has a spark gap. That's what's indicated, it's using the spark gap symbol. And all of this reference to each other is being fed to negative and positive to dump across the capacitor at 600 volts at 1100 microfarad with a 600 volt Zener diode to prevent it from overvolting. Oh, and did I mention this thing's being rotated by an electric motor plugged into your wall? So this is taking 120 volts or 220. Actually, it's indicating that this is a 120 system, but it says 220 line voltage and has a triac. Or a variac, excuse me, sorry. Which means you can adjust it for whatever country you're in. So this thing takes electricity from the wall, runs it through a full bridge rectifier, runs it across an electric motor, and I'm presuming is using the variac as a speed control for no good reason, and then dumps it across what looks like a generator that's supposed to be making three-phase power, but it has the wrong wiring for three-phase, but it's labeled that way. And it could be two-phase if that would be useful, but two-phase wiring, a two-phase signal wouldn't really be an advantage, but okay. And it's supposed to be high voltage and all this, and then it's dumped down to 600 volts from thousands of volts. So it's only taking part of the power and just doing the transitions and transferring them. Okay, we'll go with that. So this ends up just being a 600 volt power source that goes from 20 to 100 to from 20 kHz to 150 kHz. Because that's the speed this generator motor QEG, whatever it is running. Okay, but it's running off of a wall-powered motor. Okay, so let's continue. I'm just using the circuit diagram. So from there it goes to a switching circuit that's supposed to put out high-frequency pulses from DC that you just generated. I'm not even reading the notes on it. So this high voltage pulse stuff that's being turned on and off is then run through a coil, a couple of opposing coils, and then onto a capacitor with another Zener diode to drop it down to 300 volts and clean it up and make it DC as a buck boost switching circuit to make it into lower voltage DC at 300 volts DC. Then it goes to a set of capacitors with a finally we get a ground here. We got grounds in the circuit here, but there's not an indication of the fourth wire, so this isn't three-phase, so why is it labeled? Anyway, I'll stop thinking about that. Anyway, then it goes to another circuit. Now remember, it's been converted to DC and AC back and forth, presumably to change voltages. I'm assuming this has a circuit that measures everything, and let's go on. So this goes to a circuit that then takes this high voltage DC, converts it down to something 300 volts, and then it goes across a couple of capacitors labeled C3 and C4, from C1 and C2 being on the other set, and it runs through another, we're going to call it a transistor switching circuit, doesn't matter what it really is, to dump it across your load to make clean, presumably 120 volt power. And then you can flip the switch, and this circuit diagram shows it being constantly put across the power line anyway, and feed that out and have it run in a circle. So let's review. This is a generator hooked up to a motor. The motor drives the generator, and then you hook them to each other so it runs in a circle. And the excuse for saying this isn't going to lose energy and stop working is that we're using just the pulsing edges or the transitions in pulsed electrical sources. We've mislabeled this three-phase, run it off of a circuit that has 6 nodes on the armature. I'm going to call it an armature, with apparently just 2 field coils called secondary and 2 field coils called primary, and we're running this groundless until we get to the end where we have the capacitors filtering it, and then we take a filtered DC, supposedly DC power source, run it at high frequency and pulse it, and dump it across capacitors, and then turn it into low frequency so we can run our power line in a circle through all of this losses, the losses in the sledgehammer diodes. Even if you use low voltage crossing ones, even if you use active filtering, you're going to lose energy here. So what does this accomplish? This would waste, in my opinion, if they're going to be talking about using a DC motor that's running at 2 kilowatts to drive all of this. That's nearly 3 horsepower. I'm assuming they're going to be wasting 3 horsepower doing this. Well, that was an interesting ride. Thanks for watching. Have a good day. Good luck with that.